Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 30th, 2025, just yesterday. This paper tackles a task called referring audio-visual segmentation, basically finding and outlining an object in a video based on a description. They introduce a new model that's 5.0% better than previous ones on a really tough new dataset. The paper is titled, Towards Omnimodal Expressions and Reasoning in Referring Audio-Visual Segmentation, and as we'll see, this new dataset is a big step up in complexity. So to really see what makes this new dataset, called OmniAVS, so challenging, the authors provide these great examples. The prompts, or what the researchers call referring expressions, are much more complex. They're omnimodal, meaning they can flexibly combine text, speech, sound clips, and even reference images to pinpoint an object. For instance, one prompt asks the model to find an instrument played by someone of the same gender as in a reference image, which also makes a similar sound to an included audio clip. This complexity really pushes the models to understand content, not just detect it. And this next figure really drives that point home, showing a direct comparison with an older dataset called RefAVS. On the left, the prompt is simple. Who is making the loudest sound? It's just about detecting a surface-level audio property. But on the right, with the new OmniAVS dataset, the prompt is, who is most likely to be sick? This requires the model to identify a cough, and then reason, connecting that sound to the concept of being sick. The output isn't just the segmentation mask, which is the highlighted outline, but also an explanation. Building on that idea of complexity, this next table and chart puts some numbers to it. The dataset is quite large, over 2,000 videos, and more than 60,000 of those referring expressions. We see there are 8 different expression types, and videos have varying frame rates, from 3 to 15 frames per second. The chart beside the table shows the mix of these expressions, with a good balance between text, speech, sound, and image-based prompts. This scale and variety really underscore why the dataset is such a challenging new benchmark. This table then puts those numbers into perspective, comparing OmniAVS to 4 other major datasets in this area. And what you see right away is just how unique it is. If you look at the columns for referring content, you'll notice only OmniAVS lets you use audio and image prompts. It is also the only one explicitly built for reasoning and providing explanations. The check marks go all the way across the board for OmniAVS, which isn't true for any other dataset here, really highlighting its comprehensive omnimodal nature. Alright, so to tackle this new, comprehensive dataset, the authors developed the Omnimodal Instructed Segmentation Assistant, or OISA. This diagram shows how it works. On the left, it takes in the video and that complex omnimodal prompt. A key innovation here is what they call audio-visual interleaving. Instead of just looking at video and audio separately, it weaves audio clips between the video frames. This perfectly synchronizes what's happening and what's being heard. This interleaved data, plus the prompt, feeds into a multimodal LLM, which then generates a text response and the final output mask. So moving to the results, this table shows how OISA stacks up against other models on the new OmniAVS benchmark. The main metric here is the J&F score, which is a standard way to measure how accurately the model highlights the correct object. And the results are really clear. OISA, in the bottom row, achieves an overall score of 41.1%, a solid 5 points higher than the next best model. It also excels at generating explanations, with a meteor score of 21.7, which is much better than the competition. So to wrap things up, this work really pushes the field forward on 2 fronts. First, it introduces the OmniAVS dataset, a much more challenging benchmark that requires genuine reasoning about audio-visual content. Second, it delivers the OISA model, which uses clever techniques like audio-visual interleaving to set a new state of the art. That's it for this episode of the AI Research Roundup. I'm Alex. Thanks for listening.